Matrix indexing is the most important feature you need to understand to be able to extract a part of a matrix, add or remove rows and columns from a matrix, or perform any other edit in the matrix. I'm going to discuss two types of indexing that you can use to edit a matrix, and for ease of remembrance, I will name them single indexing and double indexing. So let us get started with single indexing. For single indexing, each element in the matrix is represented by a single number, and the numbering is done from column to column. So number 8 is element 1, number 5 is element 5, number 7 is element 8, and number 2 is element 9. So if you want to access number 1, you just put A, you know the position, the index is 4, and that will give you 1. If you want to access 2, you know the position is 9, and it will give you. So using this indexing, you can edit the matrix. So if I want to change 8 to -1, I just have to put 1 and then change it to -1. Then it will change my matrix. If I want to change 9 to 0, I just have to put 6, 0, and that will change my matrix. So I can extract a row using this method. So I just have to specify, for example, if I want to extract row 1, I just have to specify the index numbers of the element in row 1 correctly, which means 1, 4, and then 7. So that will give me my row 1. So I can also extract column, but extracting column in this method has a drawback, because the result of the extraction is in form of row vector. So if I want to extract column 3, so I know the elements numbers are 7, 8, and 9. So this will extract column 3 for me, but it will give it a row. So for this method, I have to put a transpose for it to come in form of column vector. So single indexing has some particular drawback which double indexing deals with. Let's have a fresh 3x3 matrix. So if we are using double indexing, you just have to know the row position and the column position of an element in order to access it. So 8 is row 1, column 1, 5 is row 2, column 2, 6 is row 1, column 3. So if I want to access this, I just have to put A, 1, 3. So that will give me my 6. If I want to access 4, I just have to put 3, 1. So I can use this to change an element. If I want to change 1 to 0, I just have to put row 1, column 2, and equal to 0. It will change my matrix. If I want to change 2 to -1, I just have to put row 3, row 3, column 3, and put it to -1, and that will change the matrix. I can also extract a particular row. So if I want to extract row 1, I just have to put row 1. So I want to extract all the elements in row 1, which means row 1, column 2, column 3. So I can specify them 1, 2, 3 to extract them. Alternatively, instead of writing the entire numbers, if I want to extract an entire row, instead of writing the numbers, I can just put column, which will suffice. So I can do that. If I want to extract row 3, I just have to put. I can also use this method to extract any column. So if I want to extract column 2, I can put 1, 2, 3, then column 2. That will extract my column 2. Alternatively, I can, instead of writing the entire numbers, I can just use the entire rows, then column 2. Then I will be able to extract it. So this method, as you can see, has more advantage when it comes to extracting column. And this method can be used to add or remove a column. In order to add a column, so I want to turn this matrix into a 3x4 matrix. So all I have to do is I want to add entire rows and column 4, which is not there yet, so I just have to add it. I write the elements I want to add, 1 2 3, and there I have it. I will have my 3 by 4 matrix. So if I want to turn it into 4 by 4 matrix, so I want to add another row, so all I have to do is specify the numbers I want in the new row, so that will give me my 4 by 4 matrix. So in order to eliminate an entire column, for example, say column 1, I just have to put the entire row column 1, and now I just put empty square bracket, and that will eliminate my column 1. So if I want to now eliminate the entire row so as to turn it into a 3 by 3 matrix, I just have to put a entire column, then put empty. So there you have it. Matrix and vector multiplication have a lot of application in engineering and sciences. To learn how to do such multiplication in MATLAB, watch the video on the screen, like and subscribe to the channel for more MATLAB tips. Thank you for watching.